Here I'm talking about space-division fabrics. There are many two kinds of switch. One is single stage, like crossbar switch, and the other one is stage switch, such as cloud switch, which is old but gold, and bion switch. In crossbar switch, I'll talk about two ways of handling crossbar output port contention, which is knockout and arbitration. Crossbar switch is pretty old. It has simple structure with low latency, suitable for multi-clouds, and importantly, no internal blocking. But also, it is out of date because of the low in scalability and no fault tolerance. The crossbar switch can suffer output port blocking, and it uses internal buffers that cross points, or buffers an output, or block at the input to solve this. Crossbar switch needs multiple distinct buffers on each output port to reduce buffer size. Using knockout switch is a good way. It uses a competition to decide which input get buffered. The input compete with each other, and the winner goes to the next round to the buffer, while the loser waits and compete again to determine next selected competitor. Arbitration is used to schedule multiple inputs with the same output to achieve a better performance and cost. The way PM offers a random selection, it randomly selects the amount requests, which are grants, and randomly accepts the amount grants, while the way iSlip maintains pointers pointing to desired input ports, which make output ports using terms. Switch has two kinds. One is distributed switch, while the other one is centralized switch. The centralized switch can have a regular internal structure and feasible to have a central control. A regular centralized space division design can conceivably be applied to distributed switching, provided component consistency is possible. Comparing to single-stage switch is more advanced and widely used nowadays. It has fewer cross points and can have various different paths. The selection in first and last stage is determined by connected input and output ports, which offers the choice of switch with a lower chance of blocking and more reliable than single stage. Cloud switching was created in 1953, designed for phone exchange firstly and out to be forgotten in time. But now, clouds have become the dominating switch architecture in data centers. People found cloud can handle fast switching perfectly. There are at least 3 stages in cloud, and each switch of a stage connects to all these switches in neighboring stages. Cloud switch is defined by K and N. In simplest case, there are N input switches in first stage, and each switch has N input and K outputs. In middle stage, there are K switches, while in the third stage, there are N output switches, and each switch has K input and N output. When K is larger than 2n-1, then there is no block, and when K is just larger than N, then cloud is rearrangeably non-blocking. Pipeline is a sequence of stages which performs a task in several steps. One stage is output buffer, the next stage is input buffer, and each functional unit takes input and produces output stored in output buffer, and these load stages work in parallel. A multiple stage network has two main attributes. Its stages are separated physically, and it can have recirculation, by which multiple logical separate stages can be created through one physical stage. Each transfer passes through successive stages, and at any instant, packets only engage one stage at a time, and a circuit engages the complete path. Bion switch uses binary to represent the output ports, and direction on each stage are specified by bit. 1 means switch to right output port, while 0 means switch to left. Bion switch cannot do multicast and only for packet switching, but it can largely reduce the switch complexity on the P ports comparing to crossbar and cloud, which is only 2P log 2P. Bion has internal blocking and output port blocking, and the chance of internal blocking is high. Buffering and dilation can solve this. Dilation sets multiple planes for later stages, moving block traffic to a higher plane, but this proportionally increases the number of switches. Also, distribution is used to reduce blocking and sorting for avoiding blocking. The blocking can be avoided if only the information destined to each output was presented out correctly input, so sorting can be used in Bion network. In a sorting network, bitonic merge sort is widely used. The sequence of comparison is set in advance and are independent of data value to allow fixed parallel implementation. A bitonic sequence is a concatenation of an increasing sequence and a decreasing sequence, or a sequence that can be shifted to become the former case. In bitonic sort, comparisons between elements are done parallelly between every 2, every 4, every 8, and so on. Smaller will float while the larger will sink until the sequence is sorted. Trapping here means recirculation, because sorting alone won't resolve output port contention. It recirculates packets to avoid prolonged resequencing. Benny's network uses multiple Banyan networks. One is standard Banyan, while the other one is distributor, used to shift input to reduce blocking, and switch controller assign paths through distributors.
created using Powtoon.